In this video we're going to have a look at 3D information. Using height information gives extra information to your research. This is perhaps the only time when we can truly say it literally adds another dimension to the study area. There are multiple ways in which you can enhance your project with 3D information. First of all, there is just visualization. And there are some simple tricks to get more insight from, for example, the lay of the land. It's not just about buildings, because some of the greatest insights, especially in relatively flat areas like the Netherlands, are about water and how it behaves. That is one of the main reasons why the Dutch height data is among the most precise and dense data sets in the world. Of course, there's also the case for solar power, which roofs or other surfaces can be used for PV panels. And talking about sun, how does a new high-rise development impact sunlight on existing structures? In this clip, we'll tell something about using height data from rasters. Using the building information from our base registration, we'll also export a model to use in Rhino for further visualization and design. Using the PDOK plugin in QGIS, you can have a look at the AHN3 data, the height model of the Netherlands. Here you can see it, the AHN data, as a colorful image. So this makes it clear which areas are higher or lower. This is interesting for general overview purposes, but otherwise really hard to use, among other things because there is no identify option, so you cannot really see how high it is exactly. There's also the possibility of downloading the data as a raster. In this case, I've downloaded the 50 centimeter resolution DTM data. This one has no buildings or trees, so it is really the surface area. For practical purposes, I've filled the holes in the dataset through an interpolation tool, and I've merged the two tiles that form this image of Delft. At first sight, this might look a bit boring. It's just a black and white image and nothing else. But this is not an image. This is an actual height dataset. So if you look closer, you can see that every pixel has a specific height. If I have a look at this one and I identify this, you can see it is minus 0 meters and 0.485. So this is real actual data. There are other ways to have a look at this data set. For example, I could change the single band gray for a single band pseudo color. This way all the data is being re-projected in a different color. Here we use a red to blue ramp, and we can invert it so that the lowest numbers become blue and the highest become red. In this case, you can see that the minimum here is minus 10. Let's change that to minus 5 and also change the maximum to plus 5. That means that everything over 5 or under minus 5 becomes really blue or red. And here you can see there is a large difference between the city center and the city area and the surrounding areas of Delft. There's another way of having a look at this data, and it is through a hillshade. And a hillshade is, well, exactly what it says. It shades the hills. Now there's not real hills, of course, but there are some. You can see the patterns in the streets and where the buildings should be. So you can really have a nice look at the area here. And this one might also be interesting. For example, if you look for older structures. Let's have a look, for example, here. Let's have a look there. You see something here in the fields, and it looks like there used to be something there, which makes, well, the grass go a bit greener. So if we have a look at that through, you can see it looks like a track here. Now this could be, for example, an old ditch that was closed down, but is still visible if you look close enough. And here in the aerial photograph, if we combine these two, you can see that, yeah, there really used to be something here. And well, currently it's not being used anymore, but you can still see the remains of it using the data. Or well, so I thought. And that was when Stefan came in and told me he knows the area, and he says there's something else going on there. And he pointed me to this map, which is the high voltage network of the Netherlands. And as you can see, there's a high voltage cable underground, and it hasn't been there very long. It's just a few years, so it's not that old. It's relatively new. Now, could I have known that? And I've been looking for the data itself, because if this is on a map somewhere, there's probably data. So what I did, I looked up the service for the Tenet assets, and Tenet is our network distributor, and I found they had an ArcGIS service, so they have a feature service. So I looked up this data set, and I noticed there's a high voltage cables underground here as well. So I copied this web address, and I copied that to my QGIS project. And here you can see that there is now an ArcGIS feature server to Tenet. You can see this underground layer, and I've added that to my map. And as you can see, it is exactly here where it should be, exactly where you see the track. So it is not that old, it is a relatively new development, but still it's underground, and you wouldn't have been able to notice it if you didn't have the data. So that is one thing, the combination of knowing the area and knowing where to find the data. If you can combine those two, that is really powerful. Another thing is that it also helps. For example, here you see some very nice works here as well. In 3D this looks really interesting. In 2D, however, if we don't use the hill shape behind that, in 2D it is all, well, it's kind of a flat surface. Now the lines you see are the open topo background. If I switch that off as well, you can see it is really a flat image. It's just an aerial picture. Using the height information, this becomes much more interesting. Now the question remains, can we use the data, the 3D buildings from the BAG, can we use that to combine together with the AHN data? And of course the answer to that question, otherwise I wouldn't be asking it, is yes, we can. And there is a very nice visualization option for it. Let's have a look at that. So we're back at our project. I've just added the 3D buildings that we made during the last video. Here they are. And if you look closely, you can see this is our project area again. So let's zoom into the faculty building here again, and let's have a look at how this looks in 3D, because there is a very nice plugin that we can use. The plugin is called QGIS to 3GIS, and this is what it looks like. When you first start it up, it probably comes up with a flat plane as an elevation model, but we have our elevation here using the DTM that we prepared. If you look very closely, you can see it is not entirely flat. There are some very small differences here. So that makes sense. I mean, this is Delft after all, it's a flat area. Next is the buildings. As you can see, we have buildings which are really flat here. So we have to use some settings on this one. And you can do a lot of things wrong here. For example, one of the things you could do wrong is say, okay, let's have a polygon at a Z coordinate that I know, for example, the roof value here. If I set it now, you can see that it still looks flat, but all the buildings are floating somewhere over the area. So that's weird. That's not what we're looking for. Let's do it differently. We make an extruded object type, and we extrude it from the ground up. So we first give this a 0 value. That means that it is absolute, and of course we have our 3D elevation model, so this is 0 above our elevation model. Next is that we're going to use an expression for the height. At this point, everything is on the same height. Let's see what that does if we apply this one. You can see that every building has the same height. That is not exactly correct. So here we can use the roof value. So now we extract the building to the roof level. Let's have a look how that one appears. Well, that looks more or less correct. You can see the buildings are on the ground. They are not floating anymore. And some buildings are higher than others. So this is probably the correct value. Now this way you have a 3D model that you can look around. And of course it is a LOD1 model. So the level of detail here is just its extruded blocks, but it gives you a good impression of an area. If you want more, you can always, of course, expand this. But for now, we have a pretty good 3D model that we can use to get a good impression of the area.